Hello everyone, welcome back to the channel. So today we would be discussing the AtCoder Beginner Contest problems, and I was able to solve A, B, C, D problem. So let's start with the D problem first, and then we'll approach and see how we will solve C, B, and A as well. So if we read the problem statement, so the problem was saying that we are given with a grid of H rows and W columns, and for each grid we are given with whether they are having a dot or a hashtag option, where each cell is either white or black, and white is being determined by a dot and hashtag is being representing the black, and we could perform this following operations this much number of times, and the operations that they say is a cell is white, then it becomes black if its adjacents are black in the 8 directions possible, and if a cell is black, it would become white. Okay, so I'm sure the problem statement was pretty clear. So what they are saying is, if you are having a particular cell, let's suppose this particular cell you're talking about, if we go in the 8 particular directions, if we see this particular 8 directions, let's suppose this particular cell is white and there is a black cell in one of these of that, so this is a black, then this particular cell will change to black, and once it's changed to black, now this particular cell was actually black, so this would change to white at t equal to 1 I'm talking about. Okay, so I thought that your problem statement is pretty clear to you. Now let's see how do we actually go and approach this problem. So I'll give you 2 steps, like I'll write down 2 steps that which you actually need to understand that is they are correct or not. Like these are what I would say the insights of the problem. So if cell is black at t equal to 0, let's talk about the time instant at t equal to 0. If cell is black, it will be white at t equal to 1, like this is we know, right? Second thing, for it to be black again, right, at t equal to 2. Now if this particular cell has to be black again at t equal to 2, then it should be white at t equal to 1, right? It should be white at t equal to 1 and a black neighbor at t equal to 1, right? If you understand, let me highlight this. So yeah, if you understand this particular problem, for a cell to be black again, right, at t equal to 2, it should be white at t equal to 1, right? It should have been white, only then it would, if it would have been white at t equal to 1 and there is a black neighbor for that at that particular instant for this particular cell, then only the cell would again comes to as black again. Okay, now let's move further. Now I'll define something. Let me define as t. Okay, so let's define t is the number of operations, number of ops performed, right? So and it would be actually going to t equals to 10 raised to power 100, and we know that it's the even number. Okay, so now let's define distance of 0, right? Let me first define what do I mean by distance only, then we'll see what do we mean by distance of 0. Okay, so what I'm saying is, let's define distance of I comma j, right? So what distance of I comma j is, that so what distance of I comma j is shortest distance from cell from cell I comma j to nearest black cell, like original black cell. Don't worry about this, I would be giving you a dry like I will give you a dry approach as well, a dry run of a particular with the time instant, then you will be able to understand it better. So okay, so let me explain you with the help of a time frame diagram to what exactly is happening in this particular question. So if we talk about t equal to 0 instant, okay, so let's make it as a start. Okay, so what would be happening is original B cells, like B is a black cell I'm writing here, original B cells are black, right, and all white cells including at distance 0, 1, 2, 3 are white. Like this is the start instant. So if we talk about t equal to 1, the distance 0 here means all of the white cells which are actually touching the black cells, distance 0 cells. So I'll write it here as well, white cells touching black, these all would become black, right, and original black cells become white. The original black cells here means these particular original cells in time equal to 0 time frame I'm talking about. Okay, now if we talk about time equal to 0, now here is the crucial thing, you need to understand it from here. So if we see the time equal to 0 instant, original black cells, like I'll simply write B, yeah, so original black cells become black again. जो original मेरे black cells थे वो black again हो जाएंगे. The here I'm black cells which I actually mean is the reason, like if we talk about वो black क्यों हो जाएंगे, because they touch the distance 0 cells. Here the original what I'm talking about is the time equal to 0 time frame वाले जो black cells की मैं बात कर रहा हूँ, ठीक है, because they would be touching the distance of 0 वाले जो मेरे जो हमने यहाँ पे convert करे थे, like all of these cells which are actually converted here as to be black, जो black हुए थे. So now the original cells were all like a common distance with them, like a distance 1 with them, right? Now distance equal to 1, the cells which are actually distance equal to 1 becomes black. The reason is because simply because they touch distance equal to 0 cells which were initially black, like which were actually turned black. And now what would happen to the distance 0 cells? Distance 0 cells will change to white, right? If we talk about t equal to 3, if I talk about t equal to 3, distance 0 cells became again black, right, because they are sharing with distance 1 they are having a, and for distance equal to 2 the cells become black. Reason is same because they are having a sharing distance 1 cells के साथ ही share कर रहे थे, right, and distance equal to 1 black cells will change to white, right? And if we talk about t equal to 4, original black cells are black, distance equal to 1 becomes black, right? Distance equal to 3 also becomes black, but distance of 0 and distance of 2 becomes white, right? So now if you see the time frames, this is the even time frame I'm talking about, this is the odd time frame. So if you see from here, if I draw some kind of a pattern from this particular thing, you'll see that at t equal to 2 distance of 1 is black, right? At t equal to 4 distance of 1 and distance of 3 is black, and if you like continue this further, you'll see at t equal to 6 distance of 1, 3 and distance of 5 would be equal to black. So if we infer something from here, if we infer that at t equal to even time, all of those cells which are actually having at distance of a particular, I would say distance is odd, So if we reach at time equal to 10 is to power 100, which would actually be an even cell, so we need to check that whether a particular cell is having a distance of odd or not after performing the DFS. So if the distance is actually odd, then I would know that this would be ending up as a black cell, else it would be ending up as a white cell. I'll just need to find the minimum distance. So this is now the question actually boils down to finding the minimum distance, and the minimum distance problem is simply a DFS problem. So I'll just show you the code as well, what I have written. So this is, you can see, so what I have done is I've started with all of the black cells, like not exactly the black cells but actually the white cells. So these all white cells would be my starting points, but not all of the white cells, only those cells which are actually having a black neighbor. So these all would be my starting points, and for each of the starting point I would be going and checking finding the minimum possible distance to each of the node. Then what I'm doing is, if the particular distance I'm talking about is reachable, like it's not -1 and the distance is odd, then I know that the final it would be a black cell, else it would be a white cell. So this is how you would be solving this particular problem. So now let's discuss the C problem. C problem was actually very easy in terms of the logic part. Most of you have thought that this would be solving using a DP problem, but actually it's not. So let's see how do we solve C problem. So C problem is saying we are giving n pieces of a rice and m pieces of some toppings, and you need to make some kind of a sushi with the combination of this, and there is a condition that a particular b of j, so what they are giving us is a particular b of j should be less than equal to twice of some a of I, right? So this is the condition that it needs to be satisfied. And okay, so most of you have thought of, let's make some kind of a DP state, dpi of j, and what will initialize us using like first I elements of a and first j elements of b. I would be finding which are my minimum sushis I can make, and then finding some kind of a transition. But like that approach is good in terms of first thought, but actually it won't work, because as you can see the constraints of NNM are 10 is to power 5. So just making the DP array only with 10 is to power 10 iterations, and like that would actually give you a TLE solution. So I think DP won't be a good option over here. What I have simply done is I've simply thought of a very greedy logic over here. I'm sure most of you have been surprised how does a greedy approach would actually work. So let's see what I'm trying to say. Now what I'm saying is, let's first sort this A and sort this B array. Okay. Now the main problem with this is that okay, so if you have identified a particular thing, I'm not saying a problem, it just make you identify this particular thing. So if you say that b of j is actually less than twice of a of I, right? So if you say there is actually a upper bound which is on b, right? So there is an upper bound on b, but there is no upper bound on a. Like a could be anything, but for a particular a, we are having some kind of an upper bound on b. So if I say like this particular array is of a and this particular array is of b, so let's suppose I'm talking for some ith here, then I would be damn sure that the j which I am picking from the sorted array of b, let's suppose so what I'm saying is, then I am actually finding some kind of a j in the sorted array which is actually less than twice of a of I, right? So like this particular operation which I'm talking about, if I would be going from this this leftmost index to here, and for this also some leftmost index to till here, I know that this I plus 1 is actually greater than this I, less than this I, then I would be knowing that if I have found some j over here, like if I made some j over here for which this particular I minus 1 is satisfied, then I know that for this particular I also I would be finding this particular upper bound in the rightmost direction, not in the leftmost direction, because these all leftmost have already considered, right? So this is why I'm trying to actually thought of to make a greedy solution and just sorted out both of the arrays. So I'll just simply show you the code what I have written. So let me grab my code, my submissions. Like I've actually made a lot of wrong submissions in the C problem, but I'll just simply show you the code. Yeah. So actually I was making some kind of a problem that I was not implementing the j pointer. some kind of that. So what I've done is I've simply taken the input int n and m, and I've defined this array. I've simply sorted both of them. So what I'm saying is, for each j, like I've made a 2-pointer approach, for each this particular j, if b of j is actually less than twice of a of I, if this particular j is being satisfied, then I'm simply considering that particular j and just increasing the counter, and finally I just printed the counter and it's been working perfectly. So I would say thinking of it as a greedy approach would give you a much benefit for the C problem rather than going with the DP solutions. Now let's jump to the B problem. So B problem was also very easy. So what the B problem is saying, you need to tell me with yes or no that whether two particular circles which are given to you are actually intersecting at some point or not. Okay. Now this was actually a very easy problem. Let's suppose we talk about this particular R1 and this particular as R2, and this is a very normal mathematical question. So what if I say I'll make you 3 particular cases. One is this, one is this, okay, and one is this. Okay. So now if I talk about these two particular cells are not intersecting, and this is actually the distance, which is d is defined as the distance between both of the centers. So this is R1 and this is R2. So if d is greater than R1 plus R2, then can I say they won't be they won't be having any point of intersection between them, right? Because they would be wide apart. So for them to have at least a point of intersection, d should be less than equal to R1 plus R2. This is the upper bound we have done on d, and for them to actually, okay, so now let's make this particular case as well. I'll just remove this, yeah, and I'll just simply write this particular case, this and this. Let's suppose the center is here, yeah. So now if I talk about this particular d, so here d would simply be R1 minus R2. Like this distance between both of them is R1 minus, like it's d is actually less than this particular thing, less than, or it's actually greater. So what I'm saying, d is actually less than, yeah, actually, so d is actually less than R1 minus R2. So still also they wouldn't be having any point of intersection. So they have to have a point of intersection when we say that both of them are colliding at just their borderline. So for them to collide, the distance between both of the centers should at least be R1 minus R2. The reason I'm taking the modulo is because I don't know which R1 or R2, whichever is greater. So here I know that this is actually the particular range of a d, and to make this satisfy, you just need to check whether this particular condition is holding or not between their centers. So this is how you would be solving this problem. Just go and find d and this R1 and R2. I'll just show you the code as well. So if my summation for the B problem, here is the B. So what I have done is, yeah, so I simply find dx and dy, which is actually the distance, and finding the distance, and there is some R1 R2, find the square of the distance. So if distance is greater than the difference squared and distance less than the sum squared, then it's a yes and it's a no. The reason I've taken the distance is because distance here, oh sorry, I've not selected it. So if I talk about the distance over here is actually under root of x2 minus x1 square plus y2 minus y1 square. So I'm actually evaluating in terms of the squares. So using the square also won't change the equation. This is how you will solve the B problem. And for A was very easy. Just use a normal while loop, and then here you will go. You just need to count all of the possible, like you just need to count all of the cases. So it's simply a very easy problem. So just go and find count. If m is not equal to 0, m is simply changed here, count plus plus, and just simply output the count. So this is how you will be solving A, B, C, D problem. I'm sure you have like the concept of how do we solve A, B, C, D. Like I would say A, B, C are easy problem on the easy. C is like I would say medium, but D is actually a good problem. So if you are able to solve A, B, C, then you are going good. Just try to be solving more and more problems so you'll be able to solve D as well. So thank you everyone. I'll see you in the next video.